So one question that pops up every once in a while is where they ask where you put like a third charge when there's two charges. So we have two charges here, and if they have the same sign, meaning either like positive, positive, or both negative, negative, where do you put the third charge? Okay. And we're going to assume that these two do not have the same. So I'm going to call this like, say, 4 microcoulombs and 10 microcoulombs. Okay. So where would it go? Well, if it went over here, like let's say it was a positive charge, well, then it would, let's see, it would repel and repel. So it's not going to cancel over there. Same thing if it was negative, it would attract and retract, and it wouldn't cancel. Basically, the sum of the forces wouldn't equal zero. Same thing on this side. So when it's the same sign, it's going to go in the middle somewhere. Now, which one is it going to get closer to? Using the concept of force equals K Q1 Q2 over R squared. Okay. So what we're looking at is we're looking at where to place that charge in relation to the distance. And this is what's called a division relationship. Division relationship means that when the numerator increases, the denominator has to also increase to maintain the same force. So when we put this somewhere in the middle, it's going to either attract and retract, or it's going to repel and repel. Either way, it's going to go somewhere in the middle. And we need to know which distance, which one is closer overall. So the larger the charge, the larger the distance. Again, if the numerator gets bigger, the denominator has to get bigger to maintain an equivalence here for the forces to cancel. Somewhere between these two charges, 1 and 2, again, we'll call this a positive charge, it's going to have to, let's say, repel force 1, repel force 2. Similarly, if it was a negative charge, then it would attract to charge 1 and attract to charge 2. So it really doesn't matter. Somewhere force 1 has got to equal force 2. So with all that in mind, what was the answer? The larger the charge, the larger the distance to maintain the same force. So that means that it's going to be closer to the smaller one. So that means, and more specifically, the magnitude of the smaller one. So between 4 and 10, it's going to be closer to the 4. If it was -4 and -10, it'd still be closer to -4. So the answer is it's going to be closer to the magnitude of the lesser charge. Lesser, fewer, smaller, you get the idea. Okay. So if you're actually asked to solve this, a lot of times they're just asking what region it's going to be in. So it's going to be somewhere closer to, of course, this one. Let's say I call this a distance x, and the distance between them is going to be d. Well, then I would have for force 1 in this setup right now, it would be k, that unknown charge negative q times 4 micro over x squared has got to equal k negative q 10 microcoulombs over this distance would be d minus x squared. If you notice, that charge didn't even matter. Coulomb's constant didn't matter. From here, you would cross multiply and solve. Or if they're asking for the distance from x, from that charge, you can just plug and chug answers in a multiple choice type setting. But that is the setup of how to solve this when the signs are the same. When they're opposite signs, so let's say we had like -4 micro and 10 micro. Okay, again, can't go in the middle. If it goes in the middle, like that's positive, it'll repel from this one, it'll attract to that one. So it's not going to be in the middle, it's going to be on the outside. Well, which outside is it going to be in? It's again going to be closer to the magnitude of the lesser charge. So that means it'll be somewhere over here in this region, in this setup. If instead it was +4 and -10, it would still be in this region because it's going to be closer to the side of the magnitude of the lesser charge, okay? So in this setup, then, it's somewhere over here. I'll call this a distance x and this a distance d. And be some unknown charge q. So in this case, we would have k q -4 micro over x squared equals k, well, it doesn't matter. So sorry, k q 10 micro over x plus d squared. The k's cancel, the charge cancels. You would cross multiply and finish solving to find the unknown distance. Although again, if it's theoretical, you would probably leave it in some type of theoretical form with x and d and probably other charges. Now, I do want to preface that if the charges happen to be exactly the same, like let's say it's 4 micro and 4 micro, well, this is going to go directly in the middle of the halfway point. So it'll be exactly at the halfway point, 1/2 d, 1/2 d is where you put that charge for it to cancel, okay? So if it's positive, positive, 4 and 4, or negative, negative, -4, -4, go directly in the middle. In the case where it's positive and negative, and again, same at 4 micro and negative 4 micro as a result, okay? Well, then there's going to be no solution there, because on the outside, if I was to try and solve that, like if I was to try to consider solving that using that scenario, so let's say I have 4 micro and negative 4 micro, which outside does it go? Because they're both the same charge overall. So it'd have to be like somewhere like infinitely away. And again, this is dealing with one-dimensional line. I'm not talking about the two-dimensional line here, which we'll eventually talk about, but that's the cases for one dimension.